Everyone, my name is Glima Anapita, AF220038. Today, my group 2 going to present to you is discharge needed on every pipes. BFC10403 Fluid Mechanic. Section 1, Dr. Hidayah binti Abdul Talib, Section 2022 until 2023, Semester 1. So, my group consisting 5 members, which is myself. Second is Farzana binti Abdul Khairul Hasmadi, AF220082, Nur Aina Zulaika binti Zamzuri, AF220005, Muhammad Haziq Zikri bin Muhammad Reza, AF220091, Fahmi Daniel bin Ramli, AF220073.
So for introduction, strong cross technique is an iterative strategy to decide the stream in pipe network framework where the source of info and result are known, yet the stream inside the network is not known. The foundation of the solid cross technique for the investigation of line stream network has changed the plan of metropolitan water supply. Water is required in many aspects of human life, including drinking, washing, cooking, and bathing. Water supply must meet the condition for water supply in a stable flow and under appropriate pressure conditions. The theory eventually became absolute due to computer solving algorithms that utilize the Newton-Raphson method or other strategy for addressing problems which eliminate the need to manually tackle nonlinear equations. Hardy cross method provides a framework for calculating the value of adjustment to be made, with each loop or junction being analyzed. The head loss between any two junctions must be the same for all roads connecting those junctions, and the inflow to each junction must be equal to its outflow. So Aina will present next slide.
Thank you, Farzana. So I'm Aina and I will present regarding problem statement of our project. So we have to determine the discharge of pipes using Hardy cross method and Darcy-Whippet method, and we have to use the given values for diameter and length of pipe, friction factors, inlet and outlet discharge. So as you can see on the right side, we have the pipe network, and figure 1 is the pipe network in town A, and figure 2 is the schematic diagram of pipe network. So below this is the table of inlet and outlet for group 2. Each group must have different values. So the equation for head loss we have to use for our group is Hazen-Williams, and as you can see we have 4 Q outlets and 1 Q inlets. That is all. So on to the next slide.
Okay, project planning flow. Understanding on how to use Hardy cross method and Darcy-Wells batch method for calculation. Next, using table 3 provided for inlet and outlet discharge. Next, watch tutorials and create tables on trials in Excel regarding these tasks, discussion, meeting, project, implementation, and presentation. And lastly, report submission on 30 January 2023. Okay. This is diagram 1, inlet and outlet discharge flow in pipe, which is Q in equals to Q out at point E, inlet 100 meter per second. The submission of outlet A, G, H, and J going to be total 100 with the different Q value. Okay. I will.
Here on the calculation front, there are 2 trials being conducted in our group. So you can see there is a table that being generated here. For column 1 is explaining 4 loops that being created in our channels. Pipes length in meter, diameter were converted from meter to inches. F is a friction factor. K can be obtained, which is K constant 10.67 L divided by CH d power of 4.87. Q can be obtained, Q divided by 1000, and HF value is 10.67 Q power of 1.85 divided by CH D power of 4.87 and NKQ. So you can see is for the loop 1, the summation of the value is of the hash f value is negative 2.16 at 4355965, and for NKQ for loop 1 negative 0.80555. So DQ value is 2.6918701007. For loop 2, you can see here is negative 16.4666008, and for the NKQ value is 6.947374, and DQ value is negative 0.76065803. Meanwhile, for loop 3, for the summation for the loop 3 is 10.3002837. For NKQ value is 1.500632, and DQ value is 6.86397295. For loop number 4 is the summation is 7.067753615 divided by NKQ value is 6.16473, and DQ value is 1.146482265. For the CH value, we are using cast iron in this particular trial. In trial 2 that we conducted, you can see is there are major difference at loop 1 and loop 2. So for the loop 1, it have a reduction from 2.6918701007 to 0.14763690. For the loop 2, DK value are increasing from 0.7606503 to 2.619098484, and for loop 3 DQ value also decrease 0.11400690. For loop 4 is DQ is 0.2179630 and 44, and that's on the part of trial 2 with a difference of Q value and hash F and NKQ value that being calculated.
One is the Hardy-Cross method. Is an iterative method for determining flow in pipe network system with known inputs and outputs but unknown flow within the network. The second one is water distribution system, models used to optimize the design of new distribution systems or to analyze major extension or changes to existing distribution systems. Next, the conclusion is the use of tough cross technique improved issues on structural analysis, findings to flow balancing in pipe networks. So from this project, Hardy-Cross method has provided perspective for engineers to deal with many problems and able to calculate the flow using application of Hardy-Cross methods. Tables of trials is easier to generate using Excel. The inlet and outlet discharge of each node were solved by drawing table 3, which is the inlet and outlet loop of our group. That's all from our presentation, and thank you.